In this video, we are going to learn how to solve a natural logarithmic equation. And the key to solving a natural logarithmic equation is to understand how to switch it from its logarithmic form to its exponential form, these natural logs. So to understand that the natural log is equal to the power you raise e to get that inside number of x. If you can understand this relationship, you can solve any of these equations. So first up, I'm going to have natural log of x plus 2 equals 3. And I want to rewrite this in its its exponential form. So this natural log is equal to the power you raise e to, so that's e to the third, to get x plus 2. And then to finish solving, I'll subtract 2, and I'll get x is equal to e to the third minus 2. And just to understand how big or small that is, we're going to use a calculator to calculate it. E is usually right above the ln key, so second natural log. So we get e to the third minus 2, which is approximately 18.08, and I'll put 55. Now this number would keep that inside the logarithm positive, so there's no really need to plug in and make sure it's right. But if you wanted to check it, natural log of e to the third minus 2 for that answer, and then plus 2 does give me 3. So it does work. Next up, I have 1.1 plus natural log of x squared is equal to 6. So I'll subtract 1.1. I'll get natural log of x squared is equal to 4.9 when you subtract 1.1. Rewriting this, I get x squared is equal to e to the 4.9 power. Then to finish solving this, I will take the square root of each side. Which is the same as raising it to the 1/2 power. And when I take the square root, I'll get the absolute value of x is equal to 1/2 of 4.9. So 4.9 divided by 2 is 2.45. So I get e to the 2.45. And then to get rid of the absolute value, I can just take the plus and minus of the other side. So plus or minus 2.45. So my two solutions are x is equal to positive e to the 2.45 and x is equal to negative e to the 2.45. And to understand how big that is, we'll just plug in e to the 2.45, and we'll get 11.5883. And that's just negative e to the 2.45, so we get negative 11.5883. Both of these, when plugged in, you square them so it'll always make it positive, so they should both work because you're squaring that number as it goes in. So you don't have to worry about a negative appearing in that logarithm. Next up, we have natural log of 2x plus the natural log of 3 equals 2. So in order to solve this, I need to get down to one logarithm, so I can do that switch. So I'll get natural log of 2x times 3 is equal to 2. And I can rewrite this as natural log of 6x is equal to 2. Then rewrite this in its exponential form. natural log is equal to the exponent, you raise e to, so e squared, to get 6x. Then we'll divide each side by 6, or rather multiply by 1/6. And you'll get x is equal to 1/6 e squared, or e squared over 6. And this number is approximately, so e to the second power divided by 6, 1.2315. So again, when plugged in, we'll give you a positive number within that natural log, so that should work out. Now we have natural log of 4r squared equals 3. So I'm going to rewrite this in exponential form. So 4r squared is equal to e to the third power. So again, that 3, the natural log is equal to 3, so that 3 is the exponent you raised e to get the inside number, 4r squared. I'll divide each side by 4. So we get e to the third over 4. Now I'll take the square root of both sides. Also the same as raise each side to the 1/2 power. Now I get the absolute value of r is equal to e, 1/2 of 3 is 1.5, over the square root of 4, which is 2. And to get rid of the absolute value, I'll take the plus and minus of the right side. And you get r is equal to plus or minus e to the 1.5 over 2. So those two approximate answers. Well, I'll whip out my calculator. E to the 1.5 divided by 2 is about 2.2408 and negative 2.2408. And that negative solution should also work because I am squaring the inside of that logarithm, any number I plug in, so it should always be a positive number there. So both solutions should work. Now I'm going to combine all of these logarithms in order to solve this. So this will be, first I need to take care of that 1/3, so I can rewrite this as the natural log of x to the 1/3 plus natural log of 2 minus natural log of 3 equals 3. Combine everything, and I'll get the natural log of, in my numerator, 2 times x to the 1/3. And since I'm subtracting by natural log of 3, that 3 is the only thing in the denominator. Then I can rewrite that in exponential form. That's equal to 2x to the 1/3 over 3 is equal to e to the third power, since the exponent is 3. I'll multiply each side by 3/2 to cancel out the 2/3. To give me x to the 1/3 is equal to 3/2 e to the third. And then I'll raise each side of my equation to the third power to get rid of that 1/3 exponent. That will not yield an absolute value of x since those are odd indices. So I'll just have x is equal to 3 cubed, which is 27, over 2 cubed, 8. And then e cubed would be 3 times 3, e to the 9th. Now this is certainly a large value. So let's see how big that would be. So 27/8 times e to the 9th would be approximately 27,347.9083. So a pretty large number. Now, the last example, I have natural log of x minus 3 squared, and this is an example of to warn you not to take out that square before you start. Because whenever you have something being squared, you could always get this plus or minus situation where they could both be true. So if you ever have a square with or a fourth power or any even power within a logarithm, don't take out that power before you start. Just keep it in there. So rewriting this, I can get x minus 3 squared is equal to e to the fourth power. Since 4 is the exponent, you raise e to get x minus 3 squared. Then we'll take the square root of both sides, which is raising each side to the 1/2 power, to get absolute value of x minus 3 is equal to e squared. 4 times 1/2 is 2. To get rid of the absolute value, I'll take the plus or minus of the right side. So I get plus or minus e squared, and then add 3, so x is equal to 3 plus or minus e squared. So 3 plus e squared, and x is equal to 3 minus e squared are my two solutions, both of which should be able to be plugged in since I'm just going to end up squaring that expression regardless. So I shouldn't have any negative values within the log. But to understand approximately how big these solutions are, we're going to plug them into my calculator. So 3 plus e squared would be approximately 10.3891. And then 3 minus e squared be negative 4.3891. And even though it's negative, it should still work because I'll be squaring that number regardless. And that is how you solve a natural logarithmic equation.